So we'll take a brief moment to talk architecture, and really a couple of key points that we want to get across here. On the left, think of this as a simple node. It could be something as small as, a one-core device, maybe 1 or 2 CPUs, very limited RAM, maybe 512 megabytes to maybe a couple gigabytes. Could be something like a flash drive, a really small flash drive, or SSDs or spinning disks, some sort of really small device or just limited footprint enterprise server, right? And in this case, we're running in a JVM. Within that JVM, we have a web server, and that web server is how all the commands come into NiFi. It goes through a RESTful API. That's what dictates what happens to the flow. It's also how you can observe what's, this is how you can look at status. Behind that then is an engine. Think of it as a sort of processing engine, which is running all of these extensions to acquire data, to assess some relative value, make prioritization decisions, and then ultimately deliver on to follow-on systems. Behind the scenes, though, so that we can provide guaranteed delivery, so that we can do really sort of high throughput and low latency processing, as well as keep track of this kind of chain of custody for data. We have 3 repositories. One keeps track of the metadata sort of about the objects going through the flow. The other keeps track of the actual raw bits themselves, right, the messages or records or tuples or whatever you have coming off of source systems. And then finally, we have a provenance repository, which is where we keep track of all the lineage information. Each of these are separate because they have different kind of lifespans, different kind of design principles behind them. They're sort of solving different parts of the problem. But if you think back to that recovery of diagnostic scenario I just described in the predictive analytics case, it's that provenance repository that would be queried to look for data that was not delivered. And then it can be recovered because it links to the content repository. And we keep the content as long as we can. We don't age it off until we have to, based on size requirements or based on age requirements. So if you take that same simple story, that same exact user experience, but now we want to scale that out. And so now we have this clustering mechanism that allows us to have a controller, which is replicating requests to all the nodes who operate the same way. They all have the same behavior, same configuration. They're just receiving different slices of data. This is how we can scale out and yet provide the exact same user experience. It's important to talk through or think about how we ensure kind of high availability or durability of the data flows. Even if a node drops out of the cluster continues on by using protocols like, for example, NiFi provides a site-to-site protocol that handles load balancing and failover automatically, shares information about what's going on in the flow, allows the client to either push or pull, both on giving data to NiFi as well as getting data from NiFi. And so your data flow continues running despite a node dropping, or if you need to add a new node, that's fine. You don't have to pre-coordinate that. We want to enable operations teams to be as flexible and agile as possible. If that cluster manager goes down for any reason, the nodes in the flow continue operating. You can't bring up the UI at that point, but as soon as you bring the NCM back online, again, you can see the flow. And so we've taken a lot of steps to make sure that despite a range of potential failure cases, that the sort of business case, this data flow requirements, that they keep running.